All right, ladies and gentlemen, thank you for flying air math on this beautiful day. Today we are going to kick it old school. And we're going to divide long division style. So today we're going to focus on long division. Tomorrow and the next day, subsequent days, we'll look at something called synthetic division. It's kind of like the shorthand version, a little bit faster. So by way of review, let's divide each of these by hand, and of course you can check with the calculator later. So this term right here is going to go inside. That's 216, and that's my dividend. And then this one here is called my divisor, and that goes outside. It is doing the dividing. Okay, now I ask myself this question. I just start with the first digit. How many of these 12s fit inside of a 2? And the answer is 0. So quickly, we already went to the next digit. And we said to ourselves, so how many 12s fit inside of a 21? And in this case, the answer is 1. So now the algorithm that you did is you now multiply these two and write the product underneath. So I write 12 underneath, and I drew my line. But what did I do to those two numbers? What do I do right here? I'm going to subtract. So everything that we're doing here pretty much is the same that we're going to do with letters. All right, now I actually do the subtraction. So I bring down the 9, and this time I bring down that 6 to here. So we ask ourselves that same question. How many 12s fit inside of 96? And this one's nice because it ends up being a whole number, 8. So now I multiply again the 8 times both of those, the 12, and I end up getting 96. Draw my subtraction bar and do the subtraction, and I bring down my 0. So when I commit to the answer, since the remainder is 0, I don't need to write the remainder, so my answer is simply 18. Now let's do that same algorithm over here. So I put the 581 inside. Put the 15 outside and ask myself what number divides, or how many times do 15 go inside of a 58? And in that case, I get 3. So I multiply to get 45, and then I subtract to get 13. Bring down the 1. Now how many 15s fit inside of a 131? And the answer, the closest, is 8. And when I do that, I get 120 when I multiply out. Algorithm subtracts, and now I get 11. And now we actually can stop here because we're not going to be dealing with the decimals. So my final result here is 38 remainder 11. That's the primary way that we're going to be writing our answers today. It is true that you could go to decimal, and it is true also that you can write it as 38 and 11 over 15. That is another answer. But just so our results don't look super complicated with fractions and polynomials, we're going to keep it as simple as remainder some term. All right, now like pure algebraites, we're going to take what mommy told you a long time ago about long division, and we're going to apply that to things you've never thought possible, to letters and numbers together. So, fun for the whole family. The idea of everything that our goal here is we like annihilation. We're annihilationists in mathematics. We want to cancel out things. We want to cancel out the first term over and over and over again. Cancel out the first term. That's the idea. So the question we keep asking ourselves is, how do I kill the first term? Using multiplication. So we're multiplication ninjas, and we're going to take down the first term over and over and over again. So I'm going to take this puppy right here and put it inside of a crate. Woof! And then the slicing and dicing happens here. I'm not advocating cruelty to puppies, by the way. Okay, so now here's the one question we keep asking ourselves. One question. Do you see this first term right here? What do I multiply this first term in order to match up this first term? The reason for it is because we're going to subtract and cancel out. So what do I multiply this by to match this? Good, I multiply by x. So notice I'm actually going to place it above because the x here is linear, I'm going to place it above the linear term, just to keep organized. So now our algorithm says whatever was on top, I now multiply and write underneath. Don't forget, you have to distribute to every term here. So x times x is x squared, and then x times negative 4 is negative 4x. Now, what do we do? Looking here, what did we do? Subtract. So, and here's an alarm bell should go off. Boop, 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 boop. Writing subtraction in the front is not enough because you have to distribute the negative across every term. So I wrote it negative x squared and changed the minus 4x to a positive or plus 4x. All right, and now we just do the actual subtraction. Notice what the goal was, to cancel out the first term. So now the second term here remains, and we get a positive 2x. So I'll bring that down, because 4x minus 2x is positive 2x. And if you recall, this negative 8, drops down. And we start all over. The algorithm says, what do I multiply this by to get the 2x? And in this case, I multiply by a positive 2. So the 2 distributes to both of those terms, and I get 2x minus 8. Draw my bar, and oppositify everything. Oppositify everything. And then when we actually add down now, or effectively subtract, we get 0. So, what is x squared minus 2x divided by minus 8 divided by x plus 4? And the answer is x minus 4. You get x plus 2. In other words, both of these are factors of that right there. Both of these are factors. Just like in problem number A, letter A, it turns out that 12 and 18 are factors of 216 because the remainder was 0. All right, so now what we're going to do in this case, we're going to see the problem where we get a remainder in this example. So again, I put the 6x squared plus 4x minus 16 goes inside. And the 2x minus 2 goes outside. And the one question I ask myself, what do I multiply the first term by to get the first term there? And the answer here, 2 times 3 gives me 6, and x times x gives me x squared. So it has to be 3x. Again, I'm lining up my linear terms here. Now I distribute the blue 3x to the red 2x minus 2 to get 6x squared minus 6x. Draw and oppositify across. Now I bring down the results. This drops out to 0, so this becomes 10x. And I bring down the negative 16. Same question. How do I get the 2x to become a 10x? So I multiply everything by 5. So I put plus 5 over there and distribute the positive 5 to the 2x minus 2 to get 10x minus 10x. Oppositify across the board there, and the 10x drops out, and we end up getting negative 6. And notice my little mistake there. I need to get rid of that x right there in the front, or on the end, because I got a little too excited there. All right, now my remainder is negative 6. So sometimes you'll see a comma like this. Sometimes it's a small r, sometimes it's a capital R. Negative 6 with a remainder like that. Any of those ways to write it is going to be fine. Notice you also might see this, probably not so much in our textbook, but 3x plus 5. And then write this as negative 6 over the 2x minus 2. You might see it written like that as a fraction, where the remainder is a fraction. But I'm just going to show you that we're not going to do that one so much. So let's focus our attention on simply remainders. The book uses a capital R. Historically, I've used a small r. The book also uses a comma, but I've never used a comma. So just know that they're all equivalent. Summarize here. This one's missing a quadratic term, so we place a 0 as a temporary holder for that. Just like we would have a 0 in the tens place built into our number system. So every term has to be represented, even if we have to write a 0. Now the divisor is 2x minus 1. Now we go through this and we ask ourselves the same question. What do I multiply the 2x by in order to cancel this one out? So in this case, it's 2x squared. So here, I write it above the now present quadratic term. So multiplying out, I get 2x cubed, and then distribute that to get minus 2x squared. Draw the bar and oppositify everything. So I bring down a positive 2x squared and bring down a negative 7x. Ask myself that same question. How do I make this 2x in the front match up with the 2x squared? That one's straightforward. I just multiply by x. And now from here, I multiply, distribute that out. So I get 2x squared minus 1x. Draw my bar and oppositify everything. And here I'm going to bring down a negative 6x. I'm running out of space. And now I bring down the plus 8. And I ask myself this question: how do I kill this one from that one? So it looks like I'm going to have a minus 3. So now I distribute that negative 3 across the board there to get negative 6x plus 3. And now we oppositify, and that becomes a negative. So down here we bring the 5. So my remainder is 5. So here's my final answer, is 2x squared plus x minus 3, remainder 5.